Hello everyone. We have another question on plane triangles. Okay, the question we have before us is in triangle ABC, angle C equals to pi over 3. Roman numeral 1. We want to prove this identity, that is, prove that sine A equals to 1/2 parenthesis radical 3 cos B plus sine B. Roman numeral 2, that side B equals to 2 side A, where the usual notation for triangle ABC applies. Find by using the sine rule or otherwise the size of angle B. Okay, now to solve this question, we can use any one of sine rule or cosine rule, okay? But the one which is best, out of these two rules, will be what? Sine rule, because when I solved the question, okay, I found that using cosine rule, okay, will be time consuming. So, but using sine rule, of course, it's not really going to take our time like that, much of our time. So now let's see how we can prove this identity and also how to find, okay, or determine the size of angle B. Okay, now we have a triangle ABC. Okay, so let me draw the triangle. We have triangle ABC. This is A, this is B, and this is what? Angle C. Opposite C is side C. Opposite A is what? Side A. Opposite B is what? Side B. Now, angle at C is pi over 3, okay, which is in radians. Okay, now, with this information, okay, we're going to use the sine rule, okay, to prove this identity. And we know that now we are giving angle C to be pi over 3. So using sine rule, okay, using the sine rule, we know that sine rule states that side A over sine angle A equals to side B over sine angle B equals to side C over what? Sine angle C. Now, this is the sine rule. This is the sine rule. Now, from this formula, now I'm going to bring out these two. I'm going to bring out A, that side A over sine A equals to side B over sine B. Okay, we're going to need that in order for us to be able to what? To prove this identity. So, bringing out this and this, okay, we have A, side A over sine A equals to B, which is side B over what? Sine B. Okay, so let's call this equation 1. Okay, let's call this equation 1. Now, from equation 1, we're going to what? We're going to construct equation 2 using equation 1. Now, what is our equation 2? Equation 2 will be writing sine A, okay, in terms of what? Sine B. What I mean is that to express sine A in terms of what? Sine B. That is making sine A the subject of the formula. So to make sine A the subject of the formula, we know that sine A from here would be, so we have side A over sine A equals to side B over sine B. So that will be A over B sine B. Yes, so we can now call this, let this be equation 2. Yeah, let this be equation 2. So this is what we're going to use to prove this identity. But let's see, we're going to get there. All right, so now, because we're giving angle C, and angle C is what? Pi over 3. Okay, so we're going to use what we call angle sum property of triangle. You know, angle sum property of triangle is the one we know to be the sum of angles in a triangle is equals to what? 180 degrees. That is, we're using so by using angle sum property of triangle, so we know that the sum of the sum of interior angles in a triangle is equals to what? 180 degrees. So that means that these three angles, angle A, angle B, angle C, okay, angle A plus angle B plus angle C will be equals to 180 degrees or 1 pi radians, because yeah, we have C, angle C is given in what? In rad, okay, in radians. So which means we're going to have angle A plus angle B plus angle C to be equals to what? 1 pi. Okay, and we're giving angle C to be pi over 3. So which means angle A plus angle B plus pi over 3 will be equals to 1 pi. So I'm going to move this to the right hand side. And when this crosses the bridge of equality sign to the other side, it's going to turn to what? Negative pi over 3. So this will be angle A plus angle B equals to 1 pi minus pi over 3. Now let's simplify the right hand side so that angle A plus angle B, okay, angle A plus angle B can be equals to 2 pi over 3. Now I'm going to express A in terms of B from here so that angle A will be equals to 2 pi over 3 minus B. Okay, so this is very important. So we can say this is what? Equation 3. That's equation 3. Okay, so now this value, okay, for A we are going to substitute this for A in this equation. So we're going to what? We're going to substitute 2 pi over 3 minus B for A in equation 1. And we know that equation 1 is A over sine A equals to B over what? Sine B. That is, side A over sine A equals to side B over what? Sine B. Okay, so now when we substitute 2 pi over 3 for 2 pi over 3 minus B for A, that means we're going to have, of course, this will be A over sine 2 pi over 3 minus B equals to B over what? Sine B. Now, we need to obtain the what? The trigonometric identity for this. Okay, we're going to use trigonometric identity to expand this. Okay, and when we do that, okay, we're going to then come back here and see how we're going to what? How is going to be applied here in order for us to prove this identity. Okay, so very important. So like I said, we have now we're going to use using trigonometric identity. Now, which of the identity? That's for sine. We know that generally sine A plus or minus B, okay, will be sine A cos B plus or minus cos A sine B. But in this case, we're going to use sine A minus B, which is sine A cos B negative cos A then sine B. Okay, so that is what we're going to apply. That is what we're going to apply in this case. So which means for sine 2 pi over 3 minus B, okay, the identity for this will be sine 2 pi over 3 cos B minus sine B then cos 2 pi over 3. Now, sine 2 pi over 3. Now, 2 pi over 3 in degrees, that will be, 2 pi. Converting 2 pi, okay, 2 pi over 3, okay, to degrees, that will be multiplying this value by 180 over pi, and that will be 120 degrees. So 120 degrees, sine 120 degrees, that's the second quadrant. That will be radical 3 over what? 2. That's root 3 over 2. So which means that sine 2 pi over 3 minus B, okay, will be equals to, so this will be root 3 over 2 cos B minus then sine B. Now cos 2pi over 3. When this is converted to, yes, cos 120 degrees. So since it's in the second quadrant, that will be minus 1 over 2 here. So this will be multiplied by minus 1 over 2. So that sine 2 pi over 3 minus b will be equals to radical 3 over 2 cos b plus, so this will be negative times negative is what? Positive. So this will be 1/2 of sine b. Okay, so now remember we substituted this value, which is 2 pi over 3 minus b, for a, okay, in this equation. Now, but we know that sine a is equals to a over b sine b, which is our equation 2. So I'm going to write this. Okay, this is sine a. Remember, a equals to, we have a to be equals to 2 pi over 3 minus b. So which means this is sine a. Sine a equals to this. Okay, so which means we can say from sine a equals to a over b sine b. So we're going to write sine a as what we have here. So that will be radical 3 over 2 cos b plus 1 over 2 sine what? Sine b. Now we know that a over b sine b is equals to what? Is equals to sine a. Okay, is equals to sine a. Now what I'm saying is that we have after we expand this identity, now we got this. Okay, now looking at equation 2, we have sine a equals to a over b sine b. Okay, so which means now we can have a over b sine b to be equals to sine a, which is right hand side will be equals to the left hand side, or sine a equals to a over b sine b. And from what we obtain here as the identity for sine 2 pi over 3 minus b, now we got radical 3 over 2 cos b plus 1 over 2 sine b, and that's equals to what? Sine a. So we just prove the identity that sine a equals to root 3 over 2, or now we know that this is common. Okay, so we factor out 1/2. So 1/2 of root 3 cos b plus sine b. So this is the what? This is the proof. We just prove that this identity sine a equals to 1/2 of parentheses root 3 cos b plus sine b, and that's what we have for Roman numeral 1. Okay, so Roman numeral 2, we are given that side b equals to 2a, where the usual notation for triangle ABC applies. Find by using the sine rule or otherwise. Okay, now we can use sine rule, and we can also use, of course, if sine rule doesn't work, then we then have to use another formula. Okay, but let's use sine rule since we are giving b to be equals to 2a. So we are giving b equals to 2a. Okay, so we know that the sine rule states that side a over sine a equals to side b over what? Sine b. And we have here that b is equals to what? 2a. So we have a over sine a equals to 2a over what? Over sine b. Now, dividing both sides by a, this will reduce to 1 over sine a equals to 2 over what? Over sine b. Okay, so let's express sine b in terms of sine a from here. So we know that when we cross multiply, we're going to have sine b to be equals to 2 sine a. So this is very important. Now, we know that sine a is equals to what we have here. That is this identity, sine a equals to 1 over 2, parentheses, root 3 cos b plus sine b. So which means now we want to find out the size of angle b. So we can say that since sine a is 1/2 of radical 3 cos B plus sin B. Okay, so we can say that sin B equals to 2 multiplied by sin A, which is 1/2 of radical 3 cos B plus sin B. Okay, when this is multiplied by 2, okay, that means 2 will cancel out, so we'll be left with sin B equals to radical 3 cos B plus sin B. Okay, now by subtracting B from both sides, okay, we're going to have 0 equals to radical 3 cos B. We can rewrite this as radical 3 cos B equals to 0. So this implies that, so when we divide this by radical 3, okay, then this will reduce to, so we have this divided by radical 3, okay. So we're going to have cos B to be equals to 0. So from here, we can say that B equals to inverse cos of 0. Inverse cos of 0. Now, from similar triangle, we know that sine 90 degrees is 1. Yeah, so cos 90 degrees is 0. Yeah, so which means the inverse cos of 0 will be equals to 90 degrees. So the value of B from here, B equals to 90 degrees, that's in degrees. So let's convert this to radians. So in radians, B will be equals to pi over 2. Okay, B will be equals to pi over 2. And this is the size of angle B. The noblest pleasure is the joy of understanding. Bye-bye.